Hi ladies, this is lesson 7.5 and it's about proportional segments between parallel lines. So in the previous lessons, we had to find the whole side of each triangle we're using, but in this lesson we're going to come up with some shortcuts that deal with specifically parallel lines. And just to stress, this has to be, these conjectures are used with parallel lines, not if you don't know lines are parallel. So you have to know that lines are parallel in order to use these conjectures. So in this first lesson, or in this first example, looking at these two triangles, LUV, which is this whole triangle, the question is it similar to MTV? So are those two triangles similar? Well, we know that angle B and angle B are congruent, so we need one other pair of congruent angles. And if these two lines are parallel, then we know angle 1 and angle 2 are going to be congruent because they're corresponding angles. And we could use that same conjecture to show that the last two angles, angle 3 and angle 4, are congruent because they're corresponding. So now, next, let's look at this. To solve for a missing segment, we have to determine whether or not the triangles are similar. So are these two triangles similar? Well, angle M is a shared angle. So looking at this triangle, triangle NML, and if we know that these two lines are similar, we know that N and O are congruent. So that's going to be similar to triangle OME. Okay, so again, you have to make sure that you match up your similar segments or similar angles. Angle N is congruent to angle O, angle M is congruent to angle M, and angle L is congruent to angle E. So now that we know that these two triangles are similar, we can solve using proportions. So what we've done in the past is set up a proportion, but we have to use the whole side of the triangle. Okay, so we have to look at this whole triangle and compare that to this triangle. So on our proportion, we would say 60 to 48. So that's our small triangle. And use a proportional statement for 60 plus y, that's the whole side of the triangle, compared to 48 plus 36, which is the whole side of the triangle. So now we have these two proportions, and now we can cross multiply in order to solve for y. So 60 times 84, which is 5040. That's equal to 48 times this whole group. So 48 times 60 is 2880. And 48 times y is 48y. So we can subtract 2880 from both sides and we get 2160 is equal to 48y. Divide both sides by 48. And we get y equals 45. So far that's how you know to solve for the missing segment. So let's see if we can come up with a shorter way for this. So the first thing you need to do is on this next page of your note sheet, there are 3 triangles, all which have parallel lines. So 2 sides are cut by a line that is parallel to the 3rd side. So please pause the video while you work, and you can unpause for the solution. You're looking for first solving for x, and then secondly, solving for those ratios. So you'll have to solve for x, and then you can get the numerical value for the given ratios. Solve for x, and what is the numerical value for those given ratios. So take a few minutes, work through this on your own, and when you're done, you can unpause the video for the solutions. So when you solved here, you should have got the first one, x is 24, the second one, x is 36, and the third one, x is also 36. And then secondly, for all of your ratios, the first two, DE over AE is 1/2, and that's the same as DC over BC. So DE to AE is the same as those 2 ratios, DC over BC. And the second one, JK over KF, is the same ratio, so it's proportional to JH over HG, and that ratio is equivalent to 3. And then the last one, PQ over QL, is proportional to PN over NM. And the ratio is equivalent to 5/9. So then let's look forward to this next conjecture, parallel proportionality conjecture. If a line parallel to one side of a triangle passes through the other 2 sides, then it divides the other 2 sides proportionally. And we saw that in the last example. We saw a line, a parallel line to the 3rd side, passing through the other 2 sides. And the 2 segments that it divided those 2 sides into are of equivalent ratios, therefore proportionally. And I think of converse, remember this word converse? That means we switch the if and the then part of the statement. That's how we get a converse statement. So conversely, if a line cuts 2 sides of a triangle proportionally, then it is parallel to the 3rd side. So that's how we can show lines are parallel, is if the 2 sides are split proportionally. So let's look at this next example, extended parallel proportionality. So this is an extension of what we just did. So let's focus on these 2 triangles first. So we know that FT is parallel to LA. So if we know that, we don't have to look at the whole side now of both of these triangles because we know that it splits those sides proportionally. So to solve for x, we can say 21 to 35. That's going to be an equivalent ratio as 42 to x. So when we solve this, if we put it in our calculator, 42 times 35 divided by 21, and that's equal to 70. Now, without another conjecture, we're going to look at this whole side and this side, and then this whole side to this side. So we're going to look at 21 plus 35. We already know that ratio over 28 is going to be equivalent to 42 plus 70 to y. So that's 56 to 28 is equal to 112 to y. So in order to solve for y, 28 times 112 divided by, so our y is 56. All right, now let's go one step forward and answer this question. Is FL to LG equal to TA to AR? So are those proportions? So FL, we know, is 35. So it's asking, is 35 to 28, is that equal to TA, which is 70, that was our X value, over our Y value? Well, let's look at the math. So 35 times 56, is that equal to 28 times 70? So yes, those two sides are proportional. So now we can form another conjecture. So these two sides to these two sides, FL to TA, to these two sides, LG to AR, those are all going to be equal proportions. So EF to ET is going to be equal to FL to TA, which is also going to be equal to LG to AR. So all three of those sets of segments are going to be proportional. So if you skip down to the bottom of your page, it says if two or more lines pass through two sides of a triangle parallel to the third side, then they divide the two sides proportionally. So we can use this conjecture now to solve for this problem. A, B, and C. Well, we know that this ratio is going to be equivalent to this ratio. So let's set a proportion for that. And when we do, we get A equals 28. Now we can use that 28 plus 14 as one side, but we don't need to. We can keep using that ratio of 14 to 10. So secondly, we know that this ratio is going to be equivalent to B over 25. And when we solve, B equals 35. And then lastly, 21 to C. So 14 to 10 is going to be equivalent to 21 to C. And when we solve, we get C equals 15. So there are definitely longer ways to do this that will give you the same answer, but with these new conjectures involving parallel lines, and again, I cannot stress this enough, these lines have to be parallel in order to use these conjectures. If you did not know that PO was parallel to any of those other segments, then you could not use this shortcut conjecture. It's only true for parallel lines. So I want you to take a minute, pause the video, work through the extra example and the closing question, and when you're finished, you can unpause for the solution. So in this extra example, x is equal to 10.5 and y is equal to 7. So now you can work your way through the closing question. And please pause the video while you work. In this last closing question, since you know that these three lines are all parallel, it splits up those segments proportionally. So you can use the ratio 6 to 5 is equal to 12 over x minus 1, and then solve for x. And when you solve for x, you get x equals 11. So please jot down any questions you have from this lesson, and we can go over them next time I see you in class. Thank you.